Okay, so just bear with me that these... Okay, now, this one was my pink triangle from earlier. This was my orange triangle from earlier. This is A, C, E, and this is D, C, B. And remember, my ultimate goal is to prove that BC is equal to AC. Now don't get lost on me, because remember, I've proven now that I've got this angle congruent to this angle. Can you see that? Okay, I'm sorry. I've got this angle equal to this angle. Okay. Now, if I can prove that I've got a couple of other sides and angles equal, then I will be able to prove that they're equal. Well, this is angle 8. This is angle 7. Nope, that's wrong. This is angle 7. Sorry. Okay? Do you see it if I pick that up, put it right there? Oh, no wonder that doesn't look like that. That's how that should go. Sorry, maybe it wasn't a great idea for me to rewrite it. There we go. Okay, so what can I prove now? The last thing I had was that angle 5 was equal to 6. Well, if 5 and 6 are equal, then 6 and 7 and 5 and 8 form a straight angle. By definition of what a straight angle is, it says the sum of angles about a point on one side of a straight line through the point is a straight angle. In other words, what they're saying is that all angles about a single point on a line equal a straight angle, or 180 degrees. So I'm going to say that angle 5 plus 8 and 6 plus 7 form straight angles. Okay, so by definition of what a straight angle is, I can say that these two and these two, when put together, are straight angles. So, number 8 is that 5 plus 8 equals a straight angle, I'm abbreviating here, and angle 6 plus angle 7 equals a straight angle. Now, I think my numbering may be a little bit different than the book, but you can get the idea, okay? And that reason was by definition of a straight angle. Is that what they use? No, it's informal statement 1I9, excuse me. Informal statement 9. I9. Okay. Now, if angle 5 and 6 equal one another, if angle 5 and 6 equal one another, and 6 plus 7 and 5 plus 8 are equal, that means they're, or excuse me, are form a straight angle. That means that 5 and 8 are supplementary, and that 6 and 7 are supplementary. Okay? So, reason 9 is angle 5 and 8 and angle 6 and angle 7 are supplementary by the definition of supplementary angles, which means that if two of them, definition of supplementary angles, which says that if two angles form a straight angle, then they're supplementary. Okay, so now that 5 and 6 are equal, and 5 is supplementary with 8, and 6 is supplementary with 7, then that means that 7 and 8 are equal. Okay, so number 10 is angle 7 equals angle 8, and that's by the fact that this is one of our statements we learned: supplements of equal angles are supplements. Okay, in other words, what's the supplement of 60? 30. Well, if I had another angle that was 60, its supplement would also be 30, so 30 degrees would be equal to 30 degrees. Okay, check this out. I've got angle 7 and 8 equal to each other. I've got this little angle DBC and little angle AEC all equal to one another. Move C up to where it belongs. Okay, so now I've got an angle and an angle And all I need to prove is that a side. Do I know anything about AE and BD? Yep, I sure do. Look back up at 7. Remember I said let's write down all our corresponding parts that we knew? Guess what? AD equals BE. So we already know that those two equal each other. So our next statement, I'm going to have to bring this over here so I can write straight. My handwriting is getting horrible. Triangle AEC is equal to, or congruent to, triangle BDC. And the reason is angle, side, angle. Now, aren't I trying to prove that BC and AC are equal? Well, guess what? I just found out they were in congruent triangles, so now AC equals BC, and that's by corresponding parts of congruent triangles are equal. Okay, so now we're done. Now, I know that took longer than what we would normally do in class, but the reason I took so long, the reason I drew all these colored triangles, is I want you to see how you attack a problem. How you can look at a triangle, because remember we started out with just a plain old triangle, how you can look at that and you can say, okay, great, well, you know what, let's find some corresponding parts of congruent triangles. Well, how do I do that? Well, let's start drawing lines that I know things about, okay? So I'm going to do one of your homework problems with you as well. But first, before we do that, I want to talk real quick about corollary 6.1. It says an equal angular triangle is also equilateral. Theorems 1 through 6 suggest additional methods for proving pairs of lines and pairs of equal angles, besides just definitions, axioms, and bisectors. Let's look at their hint right here in this box. To prove a pair of lines are equal, here's your tricks. Some of y'all are asking tricks, here's your tricks. You need to show that they are corresponding lines in two congruent triangles. That's CPCTE. The second is show that they are sides opposite equal angles in the same triangle, because guess what? Now Theorem 6 is in your bag of tricks, so you can use Theorem 6 anytime you need it to say, okay, you know what? They're opposite of equal angles, so according to Theorem 6, they're equal. So guess what? Here's you some tricks now. All right, let's look at this one over here. To prove a pair of angles are equal. 1, you're going to show those CP by CPCTE. 2 is show that the angles are opposite of equal sides in the same triangle. Okay, so here's your bag of tricks, and usually that's what you're doing. You're trying to prove that lines or angles are equal, sometimes triangles, okay? So here's 2 sets of tricks, okay? Let's go through these steps down here. It says, in working out exercises, it is very desirable that you acquire a definite method of attack so that when an exercise is assigned, you can have some system to your procedure. There's no specific method that can be used to solve all exercises in geometry. Some general suggestions, however, may be given that tell you how to start and thus give you some direction to your efforts. So it says, 1, draw carefully a figure representing what is given. And a lot of times you're given the figure, but this is what I've been stressing, is that you're going to have to learn how to draw these figures. Excuse me. Number 2, determine specifically what is to be proved. Usually it reduces to proving a pair of lines or a pair of angles are equal. Sometimes triangles. And like I said, you've already been shown where your direction needs to go. You need to think about corresponding parts, or you need to show that they're opposite of something that's already equal. Okay? So, number 3, this is on page 65, says, recall the various ways you have for proving this. Think about the ways you've already used. Number 4, determine which of these ways is best for the case at hand. It can be done by elimination if it's not evident at once. 5, determine what parts you have and what parts, if any, you lack to use this method. If you're going to use angle, side, angle, then if you're missing an angle or if you're missing a side, you need to think about how you're going to go about finding these. And that's what number 6 is. Determine how you may get the parts that you're lacking, either by a replication of the above steps or by some construction line. Okay, that's why we learned all those constructions. It wasn't so that you could become compass masters. It was so that you could use them later in proofs. And finally, number 7 says, when a direct method of a proof is not apparent, try the indirect method. And that was in the previous lesson that we learned. Okay, so I'm going to set up for us to do a homework problem together.